Hi friends, welcome to lecture number 11. It is on irrigation water conveyance. So, in the last few classes we have been talking about the soil and water and their relationship. Then after that what is crop water requirement, and then irrigation scheduling. Okay, so this is all at farm level. So, how much water really required at farm level. So, but how to get that water from a water source. So, it could be like water you have a tube well, irrigation could be using tube wells, or irrigation could be using a canal water. Okay. So, or rainfall. So, there are three ways. So, if you are using the rainfall water, I mean water from precipitation, that is called rain fed irrigation. Where tube well irrigation, you take water from tube well, nearest tube well, or canal irrigation, taking water from canals. Okay, so in this lecture we are going to talk about the how to convey the water from irrigation canals. Okay, so here if you look at this picture, this is aerial view of Indira Gandhi canal, Rajasthan. So, this is around 649 kilometer long main canal. So, basically if you see the the canal starts from Settlers River and also the Beas rivers. So, it start from here and then it passes through Punjab and then Rajasthan. Okay. Then the Rajasthan. So, basically this is a Rajasthan feeder, okay, and it is a fully lined masonry canal. If you look at this canal here, so this is fully lined masonry canal and giving water to the desert area of Rajasthan. So, this is an example of how the water is being conveyed from rivers to canals and then finally the nearest fields. Okay. So, and there are several canals are existing in India. So, this is just an example. So, and then the next is So, next is if you are looking at the canal irrigation system. So, this is basically river you have seen earlier. So, how the the origin of water course, and then from there the canal regulator, head regulator is going to regulate the flow through the canal, and then the main canal starts, and from main canal there are some branch canals, okay, and from branch canals the distributaries is going to distribute water to different miners, and then miners, and then water course, that is the field channel, and then finally it is going to reach to the field. So, from river to field, so there are different pathways. So, one is the main canal, and then branch canal, and the distributary, the miners, and then water course, that is the field channels, and then finally is the field. Okay. So, but in order to convey water from the river to the field, there are some structures, okay, or we can say the components of canal system. So, there are open channels, okay, so the pipelines and the conveyance structures like diversions and pumps, head gates, okay, and the division, so boxes and turnouts, and water measuring devices, okay, and checks, grade control structures, flumes, siphons, culverts. So, there are several structures or the components involved in transporting or conveying water from river to the field. Okay. So, we are going to talk about these components in this lecture, and then so next is see canal water supply. So, basically the canal water supply is according to the crops planted in the command area. So, the command area is the area of I mean enclosed to a particular river basin. Okay. So, here, so the water supply to the particular area is depends on the what kind of crops really planted in that area. So, and then canal system has to be designed the maximum expected demand. So, you never know in the future the demand will be more or less, but the canal system should be designed based on the maximum demand for that area, okay, to meet the maximum demand for the area. And canal layout is important as it should ensure smooth channel flow by gravity. So, the mostly since we are not going to use any pumps. So, the flow in the conveyance is taking place in canals is mainly due to the gravity flow. Okay. So, the headwork regulators the flow into the canal at the diversion structure there are. So, like here there is a headwork regulator which is going to regulate the flow to the canal from the river. Okay. So, and then the main canal takes indirectly. So, it is the main canal which takes takes directly from the river, but this is not being used for irrigation purpose. This water, this is simply going to convey the water from river to the field or branch canals, and this is called the main canal which draws water from the river, and whereas the main canal acts as feeder channel to branch canals. So, this is going to feed water to the branch channels, and the branch canals generally carry discharge to the feeder channel or major distributaries. So, then the branch canal is going to feed water to the distributaries. Okay. And then so the next is, so as I said, about 70% of water which is being conveyed from canal to the field level is going to be lost through the conveyance process because of the seepage. Seepage is the major loss from the canal irrigation supply. So, so the lining is very important in this case. So, that lining minimizes the lining basically minimizes the canal loss through the seepage, and it gives low resistance and thus reducing the friction losses. So, compared to unlined channels, so it will give low resistance, I mean the lining will give low resistance, so that the frictional losses can be reduced, and you can have the desired flow discharge at the tail end, and maintains the energy and water surface slopes low as possible. Since the friction losses are low, so the energy and water surface slopes are minimum, I mean low as possible in this case, and other things are like it is going to minimizes the channel erosion, because since the lining is there, so the channel erosion will be prevented. And then so the next is canal lining. We are going to see the different types of linings available in canal irrigation. So, here if you see this is a concrete lining. So, the picture clearly depicts the how concrete is being used to line the irrigation channels or canals, and this is the best suited for main canals and also the high initial cost, because you are investing more on cementing or concreting the line canals, and it's a long life and minimum maintenance. So, it's and the thickness of about 5 to 12 centimeter and side slopes between 1.5 to 1.5 horizontal and 1 vertical. Okay. So, 1.5 horizontal and 1 vertical. So, if this is so like that, this is the side slope you are expecting, or 1.25 horizontal to 1 vertical. So, it should be like 1.5 to 1.25, and this is a vertical. Okay. So, the channel should be like this. Okay. Right. Okay. So, this is a concrete lining. So, concrete lining is best suited for main canals and less cost involved in this. Okay. So, then long life, and the horizontal component of slope is 1.5 to 1.25 or vertical is 1 in this case. Then the next lining is shotcrete lining. In case of shotcrete lining, so what happens if there are some patches are there or any in the surface, the shotcrete lining can be used. So, here in this case basically this cement mortar, which is the ratio of 1:4 is being applied the thickness of 3.5 centimeter on the walls, and but before that a wire mesh is reinforced, and then after that this see, look at here how he is pumping this cement mortar to the wire mesh. So that the strength will be more, right, and then it is convenient for lining small sections for repair or old linings, and for placing linings around the curves and structures. So, this is very important for in ordinary cement lining case, the corners or even the curves. So, it is sometimes difficult to channel it out, whereas if you can use this shotcrete lining. So, it is very easy, simply using a gun you can apply this cement mortar to the surface. And then so the next is the brick or burnt clay tile or precast concrete tile linings. So, this is not very expensive and not skilled operators or the masons are required in this case. The top layer is generally laid in 1:3 cement mortar over 15 thick layer the plaster or 1.3 cement plaster. Okay. So, first mortar is placed, okay, so in between the bricks, and then the and then the plaster with 1:3 cement plaster is pasted on top of this cement mortar. Okay. And it does not require skilled mason or rigid quality control, and more labor intensive because it involves bricks. You have to someone has to carry bricks to the place, and then so that is why it is a labor intensive. Of course, that generates the employment. And this other lining is called boulder lining. So, in this lining this is suitable. So, when there are stones required specifications are available and abundant in local. So, when the locally there are stones available, then this boulder lining is very important. It is cheap also, right, and used for lining the earthen canal sections. Okay, so, and to reduce the resistance to flow and 20 to 25 thick cement plaster is provided. So, as the finishing surface. So, once the boulders are placed over, so then in order to plaster them, in order to get a smooth surface, so around 20 to 25 thick cement plaster is being applied on the top of the boulders. So, the next lining material is earth lining. Okay, so, in this not going to use any cement or anything. So, whatever the material present over there in place, so we are going to use the same material. So, one is a stabilized earth lining. So, here the stabilized using either clay or by adding chemicals. So, some chemicals are being added. So, that chemicals in the sense of binder. So, or for example, bentonite a clay. So, that could be added, so that it will be stabilized, okay, and loose earth blankets. So, fine grained soil is being compacted. So, that will act as the lining to the channels, and compacted earth linings, about 15% clay is spread and compacted in this case. So, for example, here in this picture, so they are not being used any the lining material, but this compaction is being used, for making the lines. And buried bentonite membranes. So, the bentonite is the clay, so which seals the pores, or also it holds the soil particles. So, then that could be a very good binder, and constructed by spreading soil bentonite mixture and covering it with gravel and compacted earth. So, recently we have used this bentonite for lining the farm ponds. So, in a nearest village, it is called Kentia village, where we adopted that village for food security project. So, the farmers are very happy, since the bentonite lining is not allowing or not seeping or not losing any water. So, that is the advantage here. And then salt cement lining, the cement and sandy soil are mixed and then compacted at optimum moisture content. Okay, so, this is soil cement lining, just a mixture of soil cement. So, it's kind of again the compaction is major operation, where this binding is really ensuring that the binding is perfect. So, the next is the plastic linings, which is very important and very of course, is expensive compared to that, but mostly the materials are being used are the plastics. So, the plastics are the low density polyethylene, and that is called LDPE or polyvinyl chloride PVC, and high molecular high density polyethylene, that is HDPE, and linear low density polyethylene, so LLDP. So, these are the plastics being used in canal lining. Okay. So, look at here the picture. So, this is how the plastic line for the irrigation channel is taking place, and the plastic films are because they are light in weight and impermeable to liquids and gases and chemically inert, okay, and flexibility to resist the microbiological attacks and ease of transportation and installation. So, these are the advantages with the plastic materials, where that can be used as promising lining material for the channels, irrigation channels. But the main problem is burrowing by rodents is menace. Okay. So, this is really the disadvantage. So, what happens is, once there is a small hole, that may cause lot of water loss or seepage. Okay. So, this is the main disadvantage in plastic lining. And then, so those are the lining materials used for canal irrigation in canal channels. And then the other things are like water conveyance structures, water conveyance structures. So, what are the structures involved in conveying water from canal to the field level, we are going to see. So, it's it could be like a pipes, it could be like open structures. Okay. So, then there are some other conveyance or structures available, we are going to see that. So, first one is a drop structure. So, the drop structure, what happen if you have the water source little bit high and all of a sudden there is a depression, right. So, you want to convey water from that surface to the down. So, without the structure, what happens, the complete is going to erode the entire soil surrounding the spot. So, constructing a drop structure really advantageous, it is clearly. So, look at here. So, the drop structures has the components are like it has a head wall, right. So, head wall exactly meeting the here the water the flow, and then it has head wall extensions to get more stability to that the structure, and there is the side wall. So, side wall and apron where this water is going to fall on apron. Okay. So, then there is a wing wall. So, this everything allows the water smoothly to the next the channel. So, then the longitudinal sill and sill, the toe wall. So, all are going to dissipate the energy and then give a smooth flow to the the channel, nearest channel. So, this the installation of this drop structure which is in operation. So, this is constructed when ground surface is of steep slopes and open structures and pipe drop structure, it could be open or pipe. So, then next structure is chutes. So, chutes, the main difference between the drop structure and chutes are, in chutes what happens. So, suppose your land grade is too much, okay, land grade is too much and it is lengthy. So, in that case what happens, keeping number of drop structures will be expensive. So, in that case the only one chute can be planned from top to bottom. So, that can convey the water from head end to the tail end, and without causing any damage to the soil. Okay. So, here basically in steep slopes a series of open drop structures are, so it is already explained. It consists of inlet and steeply sloped channels and an outlet. So, there is an inlet here, there is a channel and then outlet. So, okay. So, these are the three main parts, and it is made up of concrete or masonry structures. And then, so next is the channel crossings. So, what happened, there is a channel full of water and you want to cross from one end to other end. So, there are some structures. So, without interrupting the flow, you can also transpass the flow. So, here, so this is the invert siphon, this is called invert siphon, and this is a culvert. So, you can, so this is the flow, but still you can cross the channel, and here so still the flow is taking place and you can cross the channel here. So, this is the culvert and also the flumes. Okay. So, there is a bridge you can cross, they are the small ones, right. So, then so next is okay. So, diversion structures. So, next are the diversion structures. So, the check gate. So, check diversion structures are the structures which directs or distributes the flow or maintains the flow for the particular field. So, for example, here check gate. So, check gate is a structure where it will maintain the flow at the head end. So, it raises the upstream water level, so that water can be easily diverted to the field. So, suppose here the water level is low. So, water level is low. Okay. So, if you have a structure here, so that obstructs the flow and increases the water flow, and so that it is easier to divert this flow to the fields. And the other one is the portable check dams. So, here the operation is almost same. So, the portable check dams could be metal or plastic. So, here it is clearly showing the series of artificial or the portable check dams here made up of plastic sheets. So, water from here to here is going to stay on top and maintain some head, so that this water can be conveyed. Okay. So, this is another kind of diversion structures. And then, so next are the turnouts. So, turnouts are similar to this, the turnouts are used to convey the irrigation from distribution channel to the field supply ditch or from ditch to the field. So, here what happened, the water which is accumulated here. So, when you require water, just open the valve. So, that water will be entered through this junction box, and from there is another gate. If you open that gate, that will go to the fields. Okay. So, here the spiles are another diversion structures, where you can direct, suppose this is the head ditch cross section, your water course, and from there you want to convey water to the field. This is the field. So, and there is a pipe which can serve to convey water from the water course to the field. And there are some bamboo or concrete or burnt clay rigid PVC pipes to convey water from field to furrow, okay, or border or check basins. So, we are going to talk about these furrow, border, check basins. These are the furrow surface irrigation methods. So, in order to convey water from the water courses or water course or field channels to the field. So, these piles are really helpful. Yes. So, then the pipeline structures. So, the pipeline structures could be like the pipeline requires certain structure at specific position for proper flow and control of discharge. So, these are really helpful if you want to maintain again the flow rate or the control the flow rate. So, this for example, here pump stand. So, the pump stand is used for conveying water flow to the pump into the pipe by maintaining the required head. So, here suppose here the pipeline which is underground pipeline which is taking water to the water course or to the field. So, since if you are not getting enough head, so then you need to pump the water and create the head here, so that the underlying pipeline will have enough head. Okay. So, it ensures full flow in the pipeline and prevents pipe damage from excessive pressure. Okay. So, then the next pipeline structure is going to be gate stands. Okay. So, the gate stands. So, the gate stands are like the previously as explained. So, heat controls and flow when branch line takes off from the main line in a different direction. Suppose this is one directional flow. So, flow is taking place in this direction, right. Okay. So, you want to divert this flow from the other direction, okay, other direction. So, then you close this gate and open this gate, so that water will go to the other direction. So, these are gate stands, and then there are some air vents. So, air vents are basically used to remove air which is accumulated in the pipeline. So, then so the next is outlets. So, here the outlets are right at the field head end, so that you can open the outlet and get water from the valves. So, for example, here outlets are alfalfa valves, or there are orchard valves, okay, orchard valves, alfalfa or orchard valves. So, it basically required to regulate the flow to the field. So, it looks like this. So, when you open this, when you open this, so this is going to pop up and the water is going to come from this. Okay. So, and you can regulate this based on the height. So, if you close this, and this is going to come and sit on top of this, and then there is no water flow. So, otherwise, so this, so that you can regulate the flow to the fields. And there are hydrants and gated pipes. So, hydrants can be used to irrigate for a particular field. So, you can open this up and connect a pipeline and irrigate it. Similarly, you can open this up, irrigate to the other field. Okay. And then so next is siphon tubes. So, siphon tubes are from water course. So, this is the field channel. From field channel, so these tubes are the plastic tubes. So, the simply they cut in like 1 meter or 1.5 meter, even less, 75 centimeter. So, what happens? So, here they are going to put one end here and the other hand here, and they put what you call this, the other end is closed, and then opened up. So, closing and open will create suction here, right, create suction here, and then once the water comes from at the other end, they are going to put that in the furrow. Okay. So, similarly, there are number of, for each furrow is going to have one siphon tube, okay, or maybe 2 siphon tubes based on the the discharge required for the field. Okay, so in this lecture, so the main focus is the conveyance of water from the river, I mean from canal to the field end. Okay, so there are a lot of components involved in the whole canal irrigation system has some components. So, it has from river it is a head gate, head regulator. So, then from there the main canal starts, and from main canal to the branch canal to the distributary, and the distributary to the miners, and from the miners to the field channels or water course, and then from that it starts to the it is going to convey water to the fields. So, there are different conveyance systems, and all these this conveyance system has some components as well as structures. So, the structures are like distribution structures, or for example, drop structures. So, you have like there is a big depression, right, from sudden slope has occurred. So, you want to convey water from the upstream to downstreams, then you use drop structure. So, if the length of the drop is larger or longer, then you are going to use chute structures. Okay. So, then after that there are pipe structures. So, then there are diversion structures. Okay. And then so at the field level you are going to finally you are going to use the siphon tube. So, throughout from canal to the field level there are a lot of structures involved, okay, and also canal lining is very important in order to save 70% of water which is majorly lost through seepage. Okay. So, canal lining could be concrete lining or boulders. So, you can also use boulders and the plastics. Okay. So, all these canal lining basically save the seepage water, and also provides less erosion free of water, and also more uniform water and expected desired flow rate at the tail end. Okay. And thank you so much for your attention.